question says a 2-liter balloon holds 0.083 moles of helium. How many moles of helium are in the balloon when it is inflated to a volume of 12 liters? So in this case, we're comparing the change in volume with the change in moles. We're assuming that two things are constant, all right, the other two things in the ideal gas law, which are temperature and external pressure. So we assume that this is done, at atmospheric pressure or whatever it is, and a constant temperature. So we need to know the relationship between volume and moles, and these two things are directly proportional. The more moles of gas are in the balloon, the larger the volume. If you've ever blown up a balloon, you know this, because if you put more air into the balloon gets bigger, so the volume increases. So they're directly proportional. That's a dividing relationship. So V1 over N1 equals V2 over N2, and this is called Avogadros Law. Now we need to put the initial volume of 2 liters in, all right, and the initial number of moles, which is 0.083 moles, times, or excuse me, equals the final volume, which is 12.0 liters, times N2, which is our variable, the thing we don't know. So cross multiply, take 2 times N2, so you get 2N2, and then 12 times 0.083, and then after you cross multiply, divide by the 2. So cross multiply the two numbers, and then divide by the number across from the variable. And when you do that to two significant figures, because this has two significant figures, you find that N2 is equal to 0.50 moles of helium gas.